decimal multiplication. I can find the product of two decimals to the 10th place by using a decimal model. Spark your learning. Mr. Kasem has a collection of 100 coins from around the world. Of the 100 coins, 7/10 are in the shape of a circle. Of these circular coins, 3/10 have holes. How many coins in the collection are in the shape of a circle and have holes? Okay, so technically we can have different colored pencils to show this, but so you guys are going to need to lightly shade and then a little bit darker shade. Okay, so use the shading of your pencil to help you here. So first of all, we have 7/10, right? And then of those 7/10, 3/10 have holes. So first of all, we're going to do 7/10. So basically we have a flat. How many tenths do we have in that flat? 10, right? Okay, so we are going to lightly shade 7 of these tenths, right? So we're going to do that vertically. Okay, then how many of those 7/10 have holes in them? 3/10. So we went vertically with the 7/10. Now we're going to do a little bit darker shade. And now when I say darker, do I mean so dark you can't even see the boxes? No, I just mean a little darker than what you had your original. So then we're going to do 3 of them. And we're only going to shade the ones that are colored this way. So how many total little boxes do I have, or small cubes do I have shaded? 21, because I have the 7 going vertically, right? And then I have the 3 going horizontally. So the double shaded ones, I have 21 small cubes colored in, which equals 2100. Then what's my label? Points. Build understanding. Mrs. Varga has a collection of postage stamps. Of her stamps, 6/10 are from a country outside the United States. Of those stamps, 8/10 are from the last 5 years. What decimal represents the part of her collection that is from outside the United States and from the last 5 years? What multiplication expression models the situation? Here we have 6/10 and 8/10. So what am I going to do? So 6/10 times 8/10 is what we're looking for, right? Think about what each column of the decimal model represents. How can we use the decimal model to show 6/10? So how are we going to color that in over on our flat? We're going to lightly shade in 6/10 of the model. So we will lightly shade in 6/10 of the model. And how are we going to do that? Are we going to do it horizontally or vertically? Oh, vertically. Okay, so we need to show 6/10 on your decimal model. Okay, so we need to lightly shade 6 longs, right? So basically, I'm going to have how many shown? I'm going to shade all of them but 4. Remember, you're lightly shading it, so it's very faint, right? So you can still see the boxes. Okay, so how many of those did we shade, guys? 60. We shaded 60 of the small squares, so 60 squares. How do you represent 8/10 of the 6/10 in the decimal model? So we are going to shade in 8. So we will shade in 8 rows. Which way? Horizontally. Okay, so then we're going to do a little bit darker. We're going to shade in 8 of these. And we're going to leave how many at the bottom? 2. Okay, so how many squares are shaded to represent 8 tenths times 6 tenths? So how many small cubes or squares did we shade in? 48 squares. Because 8 times 6 is 48, right? So what part of Mrs. Vargas' collection is from outside the United States and from last year? 4,800 of her collection. Number 2, Hakeem also collects postage stamps. One of his stamps shows an older model telephone. What is the area of the stamp? So when we find area, we take what? Length times width. So what multiplication expression models the area? So we're going to write our formula. Area equals length times width. So area equals, what's our length? 1 and 2 tenths times 9 tenths, not 9. Okay, so how can you represent 1 and 2 tenths in the decimal model? So we are going to lightly shade what? We will lightly shade 1 whole flat and then 2 tenths of the other. Okay, so we went ahead and wrote that, and then we went ahead and shaded our picture. Okay, so how many squares are shaded? So how many total squares are shaded? So you know in this flat you have how many? 100. Okay, how many are shaded in the other one? 20. So 120 squares. How do you represent 9 tenths of the 1 and 2 tenths in the decimal model? So basically we shaded lightly vertically, right? So now what are we going to do? 9 of those horizontally, right? So 9 rows horizontally. Okay, so we went ahead and wrote that, and then we went ahead and shaded in our model to show the 9 tenths of the rows. So what is the area of the stamp? So how many total little boxes are shaded, guys? Do we have a hole? Yes, you're going to have a hole, right? Because even though you still have 1 row left on that flat, does the other side make up for it? Yes. So right here you have what? 90, correct? Okay, and then, or 9 tenths, correct? Sorry. So you have 9 tenths there. Then over here, or 900, over here, how many do you have? You don't have 20, you have 1,800. So you have 1,800. So what is that? 108. So 1. So you have 108 small squares, right? Or small cubes. So that would be 1 and 800. What's my answer? Or label, sorry. Inches squared, because we found the area. Jason has a silver dollar that weighs 9 tenths of an ounce. Here's a nickel that weighs 2 tenths of the weight of the silver dollar. How much does the nickel weigh? Use the decimal model. So we have 9 tenths, 2 tenths of that, and then how much does the nickel weigh? So I'm going to lightly shade how many long? 9. Vertically or horizontally? Vertically. So I'm going to shade all of this except for 1. And hopefully your shading looks a lot nicer than mine. But remember, do you shade it so dark that you can't see the line? No, you still need to be able to see the line. Okay, then of those 9 tenths, how many rows are we going to shade in? 2. And am I going to do that vertically or horizontally? Horizontally. So I'm only going to shade in 2 horizontally. So how many total small cubes do I have shaded? 18. So 18 hundredths, right? 18 hundredths of an ounce. So remember, unless you go past into another, and you can have a full flat, then do we have a whole number? No. So, but also to check it, I can take 0.9 times 0.2. That gives me 18. And then how many decimals do I have in both of those? I have 1 up here, 1 up here. So that's 1, 2. And then does that answer match what I got there? Yeah. Okay. Callie has a banner with a width of 3 meters and a length of 1 5/10 meters. What is the area of the banner? Use the decimal model. So I have the 3/10 meter, 1 5/10 meter. What is the area of the banner? So which one am I going to do vertically first? Okay, because in multiplication, can you interchange things? Yes. Okay. So we're going to do the flat. So I need all of the flat, right? I'm going to shade it vertically. And then how many of the next one? Half of it, right? Okay. Then how many am I going to shade in horizontally since we just did vertically? Remember, just a little darker, but yet you still can see the line. 3. So I'm going to do 3 over here. Remember, we don't go past the gap, right? And then I'm going to shade in 3 over here. So how many small squares do I have or small cubes do I have on that first flat? I have 30 hundredths, right? Because I have 10 vertically, right? And 3 horizontally, so that's 30. And then how many do I have over here? 15 hundredths. So what is 30 hundredths plus 15 hundredths? 4,500. So 4,500, what's my label? Meters squared, or I could say square meters, right? Okay, so I might run out of recording time, but we still need to do the whole page, right? Okay, so on your own, number 3, model with mathematics. Carter has a bottle of detergent that holds 1 8/10 liters. He fills a container that is 4/10 the size of the bottle. How much detergent is in the smaller container? Write a multiplication expression that models the situation. So we have the 1 8/10 and the 4/10, and then they want to figure out how much is going to be in the smaller container, right? So, basically we have 1 8/10 times what? 4/10. So, okay, so then we said we will lightly shade one flat and 8/10 of the other vertically. But then shade 4 rows. Then shade 4 rows horizontally. So we went ahead and did that. So how many small cubes or squares do we have on that first flat, guys? 40 hundredths, right? And how much do we have on the second one?